Question number 5. A student investigated the temperature change when magnesium was added to copper sulfate solution. This is the method used. Step number 1. Pour 30 cm cube of copper sulfate solution in a polystyrene cup. Step number 2. Measure the temperature of copper sulfate solution every minute for 3 minutes. Step number 3, which is an important step, add magnesium on the 4th minute. Step number 4, measure the temperature of the mixture at 5 minutes and then every minute up to 14 minutes. 5.1 is an AO2 question, and this question is from the required practical activity number 10. And the topics are the reactivity series, exothermic and endothermic reaction. The question is, what is the dependent variable in this investigation? We can see here in the given statement, the student is investigating the change in temperature. So the dependent variable in this investigation is the change in temperature or the temperature change. Student must know what does the dependent variable means. The dependent variable is a variable which changes when the first variable changes, or when one variable changes, the other variable is depending on the first variable. It changes on the changes of the first variable. 5.2 is an AO3 question. Suggest why the copper sulfate solution was left for 4 minutes before adding the magnesium. If we go back to the figure number 4, we see here when in polystyrene cup the copper sulfate solution was added, it was left for first 4 minutes. The reason is copper sulfate solution must reach at the constant room temperature before the reaction starts. Or the student can write the other option, the copper sulfate solution and polystyrene cup may have different temperatures before the reaction and it can affect the investigation. Therefore, copper sulfate solution and polystyrene cup are left for 4 minutes so they can reach to a constant temperature. Let's see the model answer. Copper sulfate solution reaches at the constant room temperature before the reaction. Or the student can write the other option, copper sulfate solution and polystyrene cup may have different temperature, so they must be at the same temperature before the investigation. Five point three is an AO2 question. The student need to apply the knowledge in figure number 4. Complete the figure number 4. Draw a line of best fit through all the points after 7 minutes. Extend the line back to 4 minutes. This question is from the practical activity number 10, and the topics names are reactivity series, exothermic reaction and endothermic reactions. We need to use figure number 4 and student need to draw the line of best fit from all the points after 7 minutes and need to extend the line back to 4 minutes. Let's see the figure number 4. In the figure number 4, the time is along x-axis in minutes and the temperature is along y-axis. If we see here, after 7, these points are given. We need to draw the line of best fit, which is a straight line passing through these points. We need to extend this line back to the time of 4 minutes. The student will get full 2 marks, not only plotting the straight line but also extending it to up to 4 minutes. 5.4 is an AO3 question from the topic of required practical activity number 8. It's from the same topic of the reactivity series, exothermic and endothermic reactions. The temperature change for the reaction is the temperature difference between the two graph lines at 4 minutes. So we need to know that the temperature change going on at the 4 minutes. And it is already mentioned, it is the difference between the two lines at 4 minutes. Determine the temperature change for the reaction. Use figure number 4. We need to use figure number 4 and we need to check the temperature change at 4 minutes. Let's see the figure number 4. In figure number 4, we can see that at 4 minutes, one line is this one at equilibrium. Other line is this one, which we already extended up to 4 minutes. And this is called the temperature change at 4 minutes. We will extend the line and we can see that here the temperature change is coming at 4 minutes is 26.3 degrees Celsius, which is the maximum temperature at 4 minutes, whereas the minimum temperature at 4 minutes is that is 17.5. The difference between these two temperatures is going to give me the temperature change at 4 minutes. So we need to subtract these values and the answer is 8.8 degrees Celsius. Let's see the model answer. At 4 minutes, the maximum temperature is 26.3 degree, which we can get from the blue line. At 4 minutes, the minimum temperature is 17.5 degree. And the temperature change between these two values is 8.8 degrees Celsius. 5.5 is an AO3 question and it is from the topic of exothermic reaction, endothermic reaction, and the reactivity series. And it is from the required practical activity number 10. Explain why the temperature of mixture decreases after 7 minutes. To answer this question, we need to use the figure number 4 again. From figure number 4, we can see that the time is along x-axis and the temperature is along y-axis. And we can see that after 7 minutes, the temperature is dropping. The initial temperature was 17.5, then it start increasing, and after 7, it start decreasing. The student need to explain why the temperature of the mixture decreases after 7 minutes. We know that the initial temperature at 7 minutes or the maximum temperature at 7 minutes is about 25.7 degrees Celsius. And after that, it is dropping. The decrease in temperature is actually a large amount of the heat is produced, which is going into the surroundings. Let's see the model answer by using figure number 4. At 7 minutes, the temperature is maximum 25.7 degree and starts dropping after it, showing the reaction is finished. The decrease in temperature is actually loss of the energy or the heat into the surroundings. 5.6 is a combination of AO2 and AO3 question. And this question is from the required practical activity number 10 from the topic of reactivity series, exothermic and endothermic reaction. The student repeated the experiment with an unknown metal Q instead of magnesium. All other variables are kept the same. The student recorded a small temperature change. Suggest the identity of the metal Q. Give one reason for your answer. So key information is given here. When metal Q was added instead of magnesium, the reaction was slow and the rise in temperature is not very much, which shows that metal Q is less reactive than magnesium. From our reactivity series table, we can use any other metal which is less reactive than magnesium. We can take metal aluminium, iron, or zinc as an example, and the reason is metal Q is less reactive than magnesium. Therefore, metal Q is lower in the reactivity series. Let's see the model answer. The metal Q can be aluminium or iron or zinc. Metal Q is less reactive than magnesium. Therefore, the temperature change was very small. Metal Q is lower in the reactivity series. Student can use this option to give the reason. 5.7 is an AO2 question. The student need to apply the knowledge from the topic of moles and MR, relative formula mass. A copper sulfate solution contains 0.1 mole of copper sulfate dissolved in 0.5 dm cube of water. Calculate the mass of copper sulfate in 30 cm cube of this solution. The relative formula mass of copper sulfate is given 159.5. If you look here, the units of the volume is given in dm cube, and we need to find the mass of copper sulfate in 30 cm cube. We need to convert cm cube units into dm cube, and we know that 1 dm cube is equal to 1000 cm cube. We need to convert 30 cm cube first into dm cubes. Second thing is we need to find the mass. Because we are already given moles, we need to find the moles of copper sulfate dissolved in 30 cm cube. I'm going to use the formula number of moles is equal to given mass our mr of copper sulfate. Mr of copper sulfate is already given. We can use it here. To find the mass, we need the number of moles of copper sulfate. Those number of moles which are dissolved in 30 cm cube of solution. First of all, we need to find the number of moles of copper sulfate dissolved in 30 cm cube. Before finding the moles, we need to convert 30 cm cube into dm cube. And then we are going to use the ratio and proportion method, which can help us to find the numbers of moles of copper sulfate. Let's see the possible solution. The volume of copper sulfate is 30 cm cube divided by 1000. To convert cm cube into dm cube, the answer is 0.03 dm cube. Now we're going to take the ratio between the volume and the moles. We know that for 0.1 mole of copper sulfate, the volume is 0.5 dm cube. So we used 0.1 mole and volume is 0.5 dm cube. The other volume is 0.03 dm cube, which I'm going to use here. And number of moles of copper sulfate are unknown. I use them as X. We will use ratio method, so it will be very easy to find the number of moles. By using the method, X will times with 0.5 and 0.03 will times with 0.1. And the step is solved here. And this 0.5 will go on the other side of the equality and is going to divide. So x is equal to 0.1 multiplied by 0.03 divided by 0.5, and the number of moles of copper sulfate in 30 cm cube are 0.006 moles. We got the number of moles. We're going to use these things here, number of moles. Mr is already given here. We can find the mass of copper sulfate. Let's see the following calculation. So we use number of moles here. Mr of copper sulfate is given here. We're going to use in our formula. It is go on the other side and times with it. So the mass of copper sulfate dissolved in 30 cm cube of the solution is 0.957 grams.